pH is a measure of a solution's acidity or alkalinity. The scale runs from 0 to 14. A low number would indicate a more acidic material, while a higher number would indicate a more alkaline material. 7 is considered neutral. Flexo water-based inks are typically targeted to fall between about 8 and 9.5 pH. To properly measure pH, first assemble the following items: distilled water or deionized water for rinsing off the pH meter during calibration or after measuring the ink. Deionized water is ideal as it helps to remove any impurities, salts, or other materials that may build up on the probe. Clean containers or beakers are used for rinsing the probe between measurements. Buffer solutions 4, 7, and 10 are used to calibrate the pH meter. Of course, you'll also need the ink sample and a pH meter. Prior to taking any measurements, ensure the electrode has been stored properly so the probe and junction are hydrated. If it is dried out, it must be rehydrated for at least 1 hour in the approved storage solution before calibrating the device. If a storage solution is not available, buffer solution 4 is also acceptable. Prior to measuring the pH of a solution, it is important to first calibrate the device. Typically, the pH meter is calibrated with at least 2 of 3 buffer solutions, 4, 7, and 10. Buffer solutions 7 and 10 are ideal for most Flexo water-based inks. Specific steps for calibration vary depending on the device used, but are generally simple and quick to follow. It is recommended you review the calibration steps for your specific device to ensure accuracy. Both the pH bulb and junction must be submerged to get an effective reading. Rinse the meter in the distilled or deionized water before the initial measurement and between each measurement thereafter. Once uncapped, buffer solutions 4 and 7 are only good for about 4 to 8 weeks. Buffer 10 may only last a couple weeks. The shelf life is more quickly decreased if the solution is contaminated, left uncapped, stored in hot or cold environments, or exposed to direct UV light. For the purposes of measuring ink, a weekly calibration schedule should be sufficient if the pH meter is properly stored, cleaned, and cared for. To ensure more precise pH measurements, though, it is ideal to calibrate daily or before each new ink measurement. To quickly determine if the pH meter needs calibration, you can submerge the probe into a desired buffer solution. If it measures more than plus or minus 0.05 pH from the target buffer solution value, then the pH meter needs to be recalibrated. Once the pH meter is calibrated, submerge the probe in the ink sample and allow the measurement reading to stabilize. If the pH is out of specification, adjust the ink with the appropriate additives as needed. Clean the probe and remeasure the ink, repeating this process until the ink is within the ink manufacturer's pH specifications. If the pH is too high, you may be able to reduce it with fresh ink or an additive that has a lower pH, such as a pH-balanced water. It is important not to trust untreated municipal water from the tap, as there are likely other unknown components in the tap water that could negatively impact the ink. In fact, tap water can sometimes measure at a higher pH than expected, thus having a null impact on the ink's pH or making it worse. If the pH is too low, then the ink will not remain solubilized and will begin to thicken and separate. Often during a press run, a water-based ink's pH will gradually decrease, which is why it's important to routinely measure pH throughout the press run. A low pH results in an increase in viscosity, unstable drying properties, and poor print quality, such as dirty print and color shifts. We have sped up the effects of decreasing pH by shocking this ink with distilled vinegar that has a pH of about 2 or 3. You can see how the ink begins to thicken and separate. This is what gradually happens inside your ink container, your ink chamber, and even your analog swirl cells. Adding a pH adjuster, an amine solution, helps to stabilize the ink and ensure the tiny resin particles remain solubilized so the ink performs and transfers properly.